Okay. So first thing on your calculator, let's get to know our calculators. Um, so everybody should have some kind of log button, no matter what kind of scientific calculator you have. Now, some of you have fancy calculators and some of you not so fancy, and I'll distinguish those. So if you have the basic scientific, you'll have just two options for log. You'll have log and you'll have natural log. If you have the fancy one, you can actually tell it what base you want to work in, and it will work in any base. Most of us, I'm going to plan on not having the fancy one. But try this. If you hit log 10, you should get 1. See if that works. For natural log, try natural log, type in E, and see if you get 1. I'm going to pause. I'll walk you out if you can't find something. Help each other out too if you know how to do it. So now the question is, if our calculator doesn't do it, how do we work in another base other than 10e? Now, if you have a fancy calculator, you don't have to worry about that, but you still want to listen in on what we're going to say. So we're going to talk first of all about how to change the base of something. So say I want to find log base 7 of 5. And I want to figure out what that equals. Okay? And you say you don't have a calculator that works in base 7. Well, we could change it out of this log form and into exponential form. What would it be? 7 to the power of x equals 5, right? And then what base would you like to work in? Your choice. 10. Okay. So I'm gonna take the log base 10 of both sides. If I wanted to do a different base like natural log, I could have done natural log on both sides. Both work, okay? I want to solve for x. Any idea how to get x by itself? Well, I can't divide it right now because the x is part of the 7. Okay, so there's something called the power property that we studied. That allows me to do this. Now I can divide by log 7, and I get x is equal to log 5 over log 7. And so if I want log base 7 of 5, that's the same thing as working in base 10 and putting in log 5 over log 7. And now we can use our calculators to find something that worked in a base that we originally couldn't find. So log 5 over log 7, what does that approximate to? Give me the third decimal place. 0.827. Okay. So let's go look at number 4 on our homework, okay? So we want to find log base 4 of 0.05. Okay. And at the top here, I'm going to write in general what we can do. So if I have log base b of m, we can change that. Our result was we can use log base 10 of m divided by log base 10 of b. Or we can even make it equal to natural log of m over natural log of b. And it's called the change of base formula. Why does it work? That's what we just did, right? That's what we worked through. So once you know, I mean, we could work through all those steps each time, but eventually it's going to get a little tedious. We're just going to want to jump from one to the other, okay? And so here, So I want to evaluate this. I'll go through the steps one more time because we just saw it once. So I change it to exponential form. This time we'll put it in natural log. Take the natural log of both sides. Use the power property. And then divide by natural log of 4. And then this now depends on you being able to use your calculator correctly. And it's very important that you can get the answer everybody else is getting, because this is what you're going to be using on your test in a week from today. You want to make sure you can use that calculator. No, and actually, what I want you to do is just go from here to here. I'm showing that work because I want you to see where it's coming from. So this might be the only next time I'm going to show this. Yeah. This is for the calculator portion because we're going to use a calculator to approximate this. No. But what do we get? Negative 2.161. Okay. Was everybody able to get that on their calculator? Some of your calculators are tough to work because they're backwards. Like, Chase, were you able to get that okay? All right. All right, so next one. Let's skip to 10. Okay. So the purpose of studying logs is to be able to solve exponential functions where we can't get the same base. And so here's one that no matter how hard we're going to try, we're not going to be able to get the same base. But we could still solve this using logs. And it'll be kind of like what we did in the previous problem. We decide, well, what base would we like to work in? All right, so I'm going to take the log base 10 on both sides. So by default, I won't write the base. So we get log 10, 5 minus 3x equals log of 0.041. What do you think the next step should be? I want to solve for x. You could. I'm going to use the power property. So I'm going to move that power in front. Okay. So I get 5 minus 3x, but keep that in parentheses because there's two terms there, times the log of 10 equals the log of 0.041. What did you mean drop the log of 10? Yeah. So if you notice log 10 should be 1, you can get rid of that. If you didn't notice that, it's okay. You could divide by it. You're just dividing by 1. And you're not going to mess anything up that way. So I will do the division because what if that was not a 10? You'd still be going through that. So 5 minus 3x equals log 0.041 over log 10. So this is something you would crunch in your calculator, get a decimal value, and approximate it to the nearest thousandths. So here's where you would need your calculator. And what would it be? Nearest thousandths. Okay. And then solve for x like you'd normally solve for x. So what's our next step? Subtract 5. And then divide by negative 3. And so we're going to get x is, and I should, once we use our calculator, I should use the approximate symbol, not equals. What is 3.387 divided by 3? 2.129. So 2.13 or 2.130. Would that be what you have? If we rounded to the nearest thousands? Oh, sorry, 129. Okay. So again, it's very similar to what we did in the last couple problems. I want you to try number 16, and then I'll do it with you after. Right? Try number 16. Solve for x. What base do you guys want to work with on this one? 10? That's fine. Natural log works a little better because this is an e, but doesn't matter. Both work. What are we getting? Maybe I did it wrong. I'm getting 7.272. Okay. So you have to solve for the base and the exponent first before you take the log of both sides. So I subtracted 9 and I multiplied by 2. Did you guys do that first or not? Okay. Where'd you? Oh. You don't have to use natural log. You can use log with any base you want. You can use regular log, base 10. I use log base e because what is the natural log of e? 1. So I didn't even need that. I just put it for your sake, but that's why it's natural to work. If you have e to some power, it's natural to work with the natural log. If you have 10 to some power, it's natural to work in log base 10. But you can work in any base you want to do, and it will work. Okay. Yes, natural log of e is 1. So I didn't have to write it. Okay, we're going to start to look at some application problems. We're still going to be solving and doing this kind of thing, but we're now going to apply it. And we're going to start with finances. So like if you were to get a loan or you were to invest money, these formulas would apply to that kind of thing, okay? So this next one I want to do with you is 17. So if you invest $1,000 at 5% compounded semi-annually. Semi-annually means what? Twice a year. So semi is half. So it's gonna happen every half year, so twice. Okay. How long will it take to the nearest thousandths of a year for the money to double in value? Okay. If you start with 1,000, you want to double that money. Now there's two formulas here. The second formula is for compounding continuously. So if you see a problem that says it compounds continuously, you're going to use that formula. Otherwise, by default, you're going to use this one. Okay. So you know what it means to compound. So it's how often they give. So a bank will give you maybe interest at the end of the year. One time they'll look at how much you have and pay you that percent. If you compound like biannually, twice, you get a little bit more money because they give you interest halfway through, and then when you give you interest the second time, they're giving you interest on that interest they gave you, so you get a little bit more. So the more times so if you do it quarterly, you get a little bit more money. So what if you do daily? What if you do every minute? And so continuously is do it an infinite amount of times during the year. So it's a limit. It's a calculus thing that, but we don't have to worry about that. If you take this as the limit, n goes to infinity, and work through it, you end up with this formula. And I don't know if you remember what I told you E was equal to. It looks something like this, but that's what that means. Okay. No, but we have to know how to use them. Okay, so A is the amount that we want. So how much do we want to get in this problem? How much? So we want to end up with 2,000. Okay, how much did we start with? That's the principal, that's P, 1,000. Okay, so A represents how much you end up with. P represents how much you start with. Okay, and then we have 1 plus our rate. What's our rate? Interest rate, 5%. Make sure you put it in as a decimal, not as a percent. So 0.05. N is how many times you're going to compound your interest or collect the interest or give interest. Twice. And so n happens twice in this formula. So here's another n. And then we are solving for t, this time in years. So you need to know where to plug things into that formula. Once you have that, then you're ready to solve. Okay. What do you think the first step to do is? Divide by 1,000. So you get 2 is equal to 1.025 to the power of 2t. So I just 0.05 divided by 2 plus 1 is 1.025. So now it's an exponential form. You have your argument, you have your base, you have your power. So let's take the log of both sides in whatever base we would like. What base would we like to use? Base 10? Yeah. So I'm going to take the log base 10 on both sides. So log base 10 of 2 is the log base 10 of 1.025 to the power of 2t. Okay, next step. Power property. So we get log of 2 is 2t times the log of 1.025. Next step. Divide by log. So you get log 2 over log 1.025 equals 2t. This is where you want to use your calculator now and get an approximate value for time. And we're rounding to the nearest thousands. So I get 28.071 is roughly equal to 2t, and then divide that by 2. So if you already have the value in your calculator, leave it in your calculator and divide that, because that's more exact. And that's what I'm doing as well. Okay. Yeah, so if you can be more exact, be more exact. So it takes about 14 years to double your money at 5% compounded biannually. Okay. But that's the same if you invested $1 billion in 14 years, you'd have $2 billion. So it just depends how much you invest, right? Okay. So here's another application. Let's skip down to 21. Okay, those of you in chemistry, lots of you are in honors chem, right? Half-life. Is that strontium? Is that how you say it? Okay. So here, again, here's a formula. It's an exponential formula that they use. And half-life means what? Okay. So the time it takes to only have half of whatever you started with left, right? So if there's radiation somewhere, how, in a certain amount of time, what's the half-life of that for there to be half the amount of radiation, that kind of thing. Okay. So in this case, we don't know what the amount is. You see that? I think that's the name. It's called that's the name. That's the name of it. Okay. So, but what I want you to know is we don't know how much we're starting with, and it doesn't matter. Okay? Because say we started with 100, what would we end up with? 50, half of that, right? And so you go 50 divided by 100, you end up with a half. No matter what you start, you want half of that. So what you can do is just say, I want half. If I start with 1, or whatever that is, your fraction will always end up being one half, whatever you're starting with. Does that make sense? So it doesn't matter if we know how much amount we're starting with. Okay. So e to the negative k is in this case 0.0246 t. All right, solve for t. Yeah, it's a 1. You don't have to put the 1 there. What are we getting? I can look at you. 28.177 years is the half-life. That's pretty bad. You don't want that stuff. I mean, it lasts for a long time, right? Lasts for a long time.